All right, now what about low energy? Let's flip this one around this time. If energy is restricted but insulin stays high, now we've created a bit of a problem. Because here we have the individual, once again, who has fat cells that are growing or shrinking. But if there's little energy coming in, but insulin is still high, it would be forcing, and I say it would be because now we've gone into the realm of theory, and I'll show you why in a moment. It would be forcing all of the energy into the fat cells most especially, but any of the body's cells, but again, especially fat cells. So now the fat cells are being told to grow, all while the total amount of energy in the blood is starting to go down. The fat cell doesn't care. It has plenty of energy stored. Even muscle cells don't really care. Muscle cells have a lot of energy stored as glycogen and fat. The liver's got plenty of energy. The kidneys have their own glycogen reserve. They can handle a little bit of reduction in energy in the blood. But one tissue among the trifecta of high metabolic rate organs, very high metabolic demand, doesn't store energy and must constantly be pulling in energy from the blood. But if energy in the mouth is going down, all while insulin stays elevated, which is pushing all the energy into the cells, the brain is left wondering how it's going to continue to get fed. Because if you are lowering energy in the blood, the brain isn't getting any. And so the brain starts to panic and is left with two choices. I either have to reduce my function, shut off, and reduce my energy demand, or I'm going to try to continue to work at this level and die. So it's better to go unconscious. This is essentially what happens in humans who overdose insulin, like this study with Dr. Cahill. So not only does, if there's no energy coming in and you spike insulin, glucose goes down, but then you would say, well, that's fine, Ben, because the brain has another energy source, ketones. But what happens to ketones if insulin goes up? Ketones also go down. Now you've deprived the brain of its two energy sources. No surprise that the brain shuts off. This would be known in diabetic realm, as diabetic shock. But this is why this scenario that I've outlined, namely low energy but high insulin, cannot happen. If energy is restricted, insulin must go down. Because insulin only wants to store energy. And if there's limited energy coming in, the body cannot afford for insulin to stay high. Now, therein lies the rub. Therein lies the problem with virtually every study that is comparing low-calorie to low-insulin diets. Or to say that another way, a low-fat diet, hypocaloric low-fat diet versus a low-carb diet. Now, as a reminder, and this is, once again, data that is just directly superimposed on a figure. We have done these experiments in my lab, and we're going to publish them soon. You can see that it's only carbs that have a substantial or any demonstrable effect on insulin at all. Now, those who were in Dr. Kutnick's talk this morning, you're saying, well, Ben, he showed an insulin curve. These are non-diabetic. If a person is a diabetic, they will have an exaggerated response to the protein that a non-diabetic won't have. So these are real human data. And my data from my lab is exactly like this. Although I'm not showing mine, I'm showing someone else's work here. This is for an insulin-sensitive person, non-diabetic. If it were an insulin-resistant person, the insulin spike to glucose would have gone up substantially higher and taken an hour or two longer to come back down. Just as a reminder.